Okay, so here is the statistics question that we have. On average, nationwide, batteries tend to last 54 months. Another company is interested in knowing if they have successfully increased the battery life at a level of significance of 0.01. If a random sample of 40 batteries is found to have a mean of 56 months and a standard deviation of 5 months, answer the following questions. Construct a 95% confidence interval for the mean battery life for this manufacturer. Determine the test statistic to test the given claim, and determine the critical values to test the given claims. I'm going to break this down so it seems a little less scary, and we will start with the information that is given to us in the problem itself. So first we need to identify the different things that we can see in the problem itself. So it says on average the nationwide batteries tend to last 54 months. So what this number is, it isn't our X bar. Our X bar is our mean of our sample, but this is the mean of the population. And so of all of the batteries in the entire nation, they have a mean of 54 months. And we call that mu 0. It's just a fancy way to say the average of all of the batteries nationwide is 54 months. So we're going to write 54. Another company is interested in knowing that they have successfully increased the battery life at a level of significance of 0.01. So we call level of significance, level of significance, we call alpha. Okay, so a little lowercase alpha is written, I can't do it very well, but something like this, and it is 0.01. If a random sample of 40 batteries, so we have a random sample of 40 batteries, so what we call that is N. When you have a number of things is called N. A capital N would indicate a population number, whereas a lowercase n is a sample number. So random sample of batteries is 40. So that makes N 40. It is found to have a mean of 56. This is where our X bar comes in. So this is the mean of the sample. So the mean is 56. X bar equals 56. And a standard deviation of 5 months. And so standard deviation can be written a couple of ways, but as it is the standard deviation of the sample, it will be a little s. So standard deviation was 5 months. So S equals 5. And that's all of the information that we have in that first paragraph. So we are going to use these numbers that we got on answering the questions. Okay, so we're asked to construct a 95% confidence interval for the mean battery life for this manufacturer. And this is what that formula looks like, which is kind of scary, but we already figured out all of those numbers over here. So X bar is just 56. So think of this as just a regular symbol in algebra. Plus or minus Z star, which is the confidence interval, I'll get to in a second, and multiplied by the standard deviation divided by the square root of the number of observations, which we already have our number of observations, our standard deviation, and our X bar. For the Z star, which is the confidence interval, I have a note card here with common Z intervals, and this is something that you can just jot down a lot of times. These are the percentages that they'll ask for in questions. So common Z star intervals, we want a 95%. So our Z star is just 1.960. So I will rewrite this equation using the numbers that we know. So this is what the formula looks like when we plug in the numbers that we know. 56 as the x bar, 1.960 as I showed you earlier on here is a common z-star interval. 5 is our standard deviation, or S, sigma, and n is our sample size, 40. So it looks a lot less scary in this form. So what I do next is I calculate this side of the equation first. Leave the 56 plus or minus alone and just do the right side of the equation. And how I found the best way to do it on the calculators, I've got my calculator right here, is I do the parentheses first. 5 divided by the square root of 40. So in here I do 5 divided by the square root of 40, enter, is that big long number. And I need to multiply it by 1.960. So you just leave it just like this, and then you multiply, and it'll take the answer multiplied by 1.960. And we get this big long number. So let me pull this down a little bit. So I just shortened this number to this. And the longer you keep the number, the more accurate it's going to be. I went ahead and did 4 digits, and I actually think I rounded wrong probably. No, I rounded right, but my answer ends up being a little bit off in the end. But it's just because I didn't use the whole number. When you use the whole number, it changes your answer because the number is quite much longer than the calculator is even showing it. So from here, I just divided this into 2 separate problems. 56 plus 1.5495 and 56 minus, because we have the plus and the minus here. So we divide into 2 problems and we get 2 different answers. Those are our answers, and we write them like this. So basically what this is saying is that we are 95% sure that all of the batteries that you could test will fall between 54.451 months and 57.5495 months. So it will fall somewhere in there. We're saying that we have a 95% chance. So there's a little bit on either side, but this is most likely what you're going to get. Now, if you wanted to do that in your calculator, I wrote out how to do all of that in your calculator with the touch of a couple of buttons. I'll give you a look at it, and then so we're going to go to hit the stats button, go over to tests, and then down to number 7, which is the Z interval. And make sure that you're on stats in this screen. And then we input our information, which it saved from when I did it. So our sigma is 5, our x bar is 56, our n is 40, and our confidence level, we want it to be 95%, and so it doesn't understand percent, so we've got to make it a decimal. You just move the decimal 2 places over, so 0.95 is our C level, and go down to calculate, and it gives us the same answer that we got right here. So your answer shows up here, 54.451, 57.549. And like I said, mine was off a little bit because really if this was rounded, it would be 550, but that is your answer for number 1. Okay, so the second question asks us to determine the test statistic to the given claim. So the test statistic, all that it really is the statistic minus the parameter divided by the standard deviation. So I have all of our numbers over here before that we found earlier. And there are 2 possible formulas that you can use for this. Now, typically, the t-score is used to evaluate a small sample, and the z is for a larger sample, but the z requires this sigma right here in the z formula is the standard deviation of the population, which we don't have. We do have the standard deviation of the sample, so we have to use this formula right here. But in case you need a population formula in the future, that is the z formula there. So this is the formula that we're going to use, and I'm just going to take these numbers that we already have found and plug them into this formula. And it looks something like this. I messed up and accidentally wrote in here instead of 40. So I kind of had to write over that. So I always start with the top. It's just 56 minus 54. It's just 2. So the top of it will become 2. And the bottom is 5 divided by the square root of 40, which happens to be 0.7906. We find that again by doing 5 divided by second square root of 40 and press enter, and we get that big long number. And so we want our answer to be as accurate as possible, and if we rounded this number and we just use 7906, our answer would be a little bit different than this right here. So I'm going to show you how to get an exact answer. So we're going to do 2. We just did the division right here, and we still have the answer sitting right here. It's very important that you leave this sitting here. And we're going to do 2 divided by, and we're going to hit the second key and this key, which is ANS. So it says 2 divided by ANS, and what that is the answer. So it uses this whole answer, even the numbers past where we can see it uses the whole answer, and we press enter. And it gives us the most accurate number that we'll be able to get. So that I rounded that number off, and that is your answer. And your answer can be given in 2, 3, 4 decimals, however many decimals you want to give. Typically, you'll see 3, so this would be rounded up to 2.53, but sometimes it will go farther as well. So that is the entirety of the question number 2, the test statistics. So for our final question here, they want us to determine the critical values to test the claim. And critical values are done on the calculator, but first we need to make a diagram and kind of understand a few things. So over here I put our numbers that we've been using all along. I just copied them down on this piece of paper. And the number that's going to be really significant this time is the alpha. The 0.01 is part of our critical values. So what the alpha is it's telling us the level of significance. It's a lot like our 95% earlier, our confidence value. This is a new type of confidence value. And 0.01 happens to be 99%. We get that from 1 minus alpha. So whatever alpha is, when we want to find this number, it's 1 minus alpha. So 1 minus 0.01 is 0.99, which is 99%. So t is the number that we're looking for here. And if all of this is 99%, then the rest of it is divided on either side. So we only have 1% left. So 0.5% down here and 0.5% up here makes a total of 100%. So what this is interested in knowing, what we need to know for the calculator input is how much is to the left of t. That's what we're concerned with. How much of this is left of t was 99.5%, right? So t is only 0.5% up here. So something that you'll see in the calculator is df. And df stands for degrees of freedom. And how we find degree of freedom is just n minus 1. I don't know why they don't just call it n minus 1. We want to call it degrees of freedom to make statistics more confusing, I suppose. So in your calculator, you're going to press the second key, go to vars, and it will be option 4. So second vars. Option 4 is INVT. That's where we're going. So yours may look different than this. You'll see on the next screen how it will look if it doesn't look like this. But our area, remember I told you, is everything left of t. So it's 99.5%, which as a decimal is 0.995. And our degrees of freedom is n minus 1, which our n is 40. So our degrees of freedom is 39. N minus 1. So then we're going to paste it in. So if your screen didn't have that, then it's just going to have this. What will happen is it will say INVT and it will open a parenthesis. And you put in your 0.995 and then a comma and then your 39 and close your parentheses. So just make it look exactly like this. And then press enter and it'll think for a second and gives us a number. And that is our answer. 2.7079 is our critical value.